Here's your quick review on graphing parabolas. So we are going to be graphing quadratics. Now remember that the graph of a quadratic is a parabola. We have three different forms that you are going to see equations in. The first one, standard form. Y equals ax squared plus bx plus c, where our axis of symmetry is x equals negative b over 2a, and in order to find the vertex we got to plug that back in, and then you're going to make a table of values and plot points. So let's do an example with that. Say we have the equation y equals x squared plus 4x plus 8. We find our axis of symmetry by doing x equals negative b over 2a, x equals negative 4 over 2 times 1. It's negative 4 over 2. That means x is equal to negative 2. I then need to plug that back into my equation to solve for y. So y equals negative 2 squared plus 4 times negative 2 plus 8. 4 plus negative 8 plus 8. Those cancel out and we just get y equals 4. So my vertex is going to be at negative 2, 4. So I'm going to make my table of values. I'm going to put my vertex right in the middle. And I'm going to pick points that are to the left and the right of my vertex. Now remember, if I go equal increments to the left and the right, I'm going to have symmetry on the y's. So I only have to solve for my y value twice. I'm going to choose the points negative 1 and 0. Then I'll have negative 3 and negative 4. So if I plug in 0 into my equation, 0 plus 0 plus 8. So I'm going to get an 8. So both of those y values will be 8. Now I got to plug in negative 1. Y equals negative 1 squared plus 4 times negative 1 plus 8 gives me 1 minus 4 plus 8. 1 plus 4 equals 5. So now I'm going to go ahead and graph that. Remember, my vertex is at negative 2, positive 4. Then I have a point at negative 1, 5. And at 0, 8. I also have a point at negative 3, 5. And at negative 4, 8. This point right there is my vertex. The vertical line running through my vertex is my axis of symmetry. And because I do not cross the x-axis anywhere, I do not have any roots on this problem. The next form that we have is vertex form. This equation is y equals a times x minus h squared plus k, where my axis of symmetry is equal to h, and my vertex is h comma k. Just like with absolute value, there is a negative already in the equation. So if this is a negative, we have a positive h. If this is a plus sign, we had to have a negative h in order to get the minus sign in the equation. So let's try one of those problems. If we have the equation y equals 2 times x minus 1 squared plus 2, I know that my vertex is positive 1 comma 2. There's a negative there. There was a negative in the original equation, so it is a positive 1. My axis of symmetry is the same thing with the h. There's a negative there. There's a negative there, so this is a positive 1. Now I need to find 4 other points in order to plot my parabola. Make a table of values, put my vertex in the middle, choose points to the left and the right. 0, negative 1, 2, 3. If I plug in a 0, y equals 2 times 0 minus 1 squared plus 2. Y equals 2 times negative 1 squared plus 2. Y equals 2 times 1 plus 2. Y equals 4. Now if I plug in a negative 1, y equals 2 times negative 1 minus 1 squared plus 2. Y equals negative 2 squared plus 2. Y equals 2 times 4 plus 2. Y equals 8 plus 2. Y equals 10. So now I can plot those points. I have my vertex at 1 comma 2. And I have a point at 0, 4, point at 2, 4, 3, 10, which is going to be way up there, negative 1, 10, connect my dots, and there's my point. Again, this graph does not cross the x-axis, so I have 0 roots. All right, our last form for graphing parabolas is intercept form. This is y equals x minus p times x minus q. Our axis of symmetry is x equals p plus q divided by 2. So p and q are our x-intercepts. They are the roots of the parabola. If we find the average of the roots, we will find the middle part of the parabola, which is the axis of symmetry, the line that splits the parabola so that it is symmetrical. And so we add p plus q divided by 2. Remember, these are negative signs already. They are minus in the equation. So if we have a positive sign in here, it's going to have been a negative number. So let's look at the example. Y equals negative x plus 1 times x minus 5. So I can already fill out my table of values with 2 points. I know that I'm going to have a root at negative 1 comma 0. Remember, on the x-axis, y is always 0. I had a plus sign here. It's supposed to be a negative sign, so in order to make it a negative, this had to be, p had to be a negative 1. I'm also going to have a root at 5 comma 0. There was a negative here and a negative there, so this is a positive 5. And again, the y value is always 0 at the x-intercepts. I can solve for my axis of symmetry. X equals negative 1 plus 5 divided by 2. Remember, p is a negative 1, q is a positive 5. That's 4 over 2. My axis of symmetry is 2. So my x-coordinate on my vertex is 2, and now I just got to find my y. Y equals negative 2 plus 1 times 2 minus 5 negative times 3 times negative 3. Negative 3 times 3 is negative 9 times this negative gives me a positive 9. And now I need to pick 2 more points. 0 is 1 away from this negative 1. So if I go 1 the other direction from 5, I will also be at 4. 2 and 0 are 2 spaces apart. 2 and 4 are 2 spaces apart. So I know that I'm going to be symmetrical. If I plug in a 0 into my equation, y equals negative 0 plus 1 times 0 minus 5. I get negative times 1 times negative 5. Negative 5 times 1 is negative 5 times this negative out here becomes positive 5. So now I have my 5 points. I can plot my parabola. I have a point at 2, 9. I have a point at 0, 5, and 4, 5. Oops, 0, 5 is over here. And 4, 5. And then I have a point at negative 1, 0, and 5, 0. And there's my graph. Those are the 3 different ways to plot a parabola. Remember, you need 5 points. 5 points for a parabola where they will mark you down. I will now also post a video on how to solve quadratics.